Lake Tahoe has surged to 6,229 feet, its absolute maximum capacity. And right now, seismic pressure is building on a fault that could produce magnitude 7.3 devastation. After 5 years of brutal drought, California's most famous alpine lake transformed almost overnight. Record snowpack and atmospheric rivers pushed billions of gallons into the basin faster than anyone predicted. What should be a celebration has become a geological nightmare. Hidden beneath those crystal-clear waters lies one of California's most dangerous secrets, a massive fault line running directly under the lake. Scientists say it is 4,000 years overdue for a catastrophic rupture. Now, all that water, billions of tons of pressure, is pressing down on fractured bedrock that has been building tension for millennia. Seismologists are watching instruments around the clock. Small tremors are increasing. If that fault snaps while the lake sits at maximum capacity, underwater landslides could trigger a tsunami that devastates shoreline communities in California and Nevada within minutes. Is the water that saved California from drought about to trigger something far worse? The number reads 6,229 feet above sea level. This is Lake Tahoe's absolute maximum legal capacity. That threshold was set by a federal court decree more than a century ago. It is the highest the lake is ever permitted to rise, and right now the water is pressing against that limit with nowhere left to go. 5 years ago, this same lake told a very different story. Drought had drained Tahoe to levels that exposed ancient tree stumps along the shoreline. Boat ramps sat useless, ending dozens of feet from the receding waterline. Marina owners watched their businesses suffer as the lake shrank month after month. Climate scientists warned that California's water crisis might never fully recover. Then came the atmospheric rivers. Storm after storm slammed into the Sierra Nevada beginning in late 2022. Record snowpack accumulated across the mountains, measuring 237% of normal in some monitoring stations. When spring arrived, the melt began. Billions of gallons poured into the Tahoe Basin faster than hydrologists had modeled. The lake rose 4 feet in a single season. Water managers scrambled to open the dam gates at the Truckee River outlet, releasing maximum legal flows downstream. It wasn't enough. By early 2024, Lake Tahoe reached levels not seen since 2019. The transformation stunned longtime residents who had watched the drought consume their beloved lake for half a decade. Tourism officials celebrated the recovery. Kayakers and swimmers returned to beaches that had been dry and cracked just 2 years earlier. Headlines proclaimed California's water miracle. But beneath the celebration, a different story was emerging. Scientists monitoring the region noticed anomalies in their data that had nothing to do with water levels. Seismographs positioned around the Tahoe Basin began recording increased activity, small tremors, subtle shifts, patterns that demanded attention. The lake had returned to its maximum capacity. The drought was over. But something else was happening far below that pristine blue surface. Something that would transform celebration into concern and concern into alarm. Beneath Lake Tahoe's pristine surface lies one of California's most dangerous secrets. The West Tahoe Fault is a massive geological fracture running directly under the lakebed for approximately 25 miles. Scientists have known about this fault for decades, and what they've discovered about its potential keeps seismologists awake at night. The West Tahoe Fault is capable of generating earthquakes up to magnitude 7.3. To understand what that means, consider the 1989 Loma Prieta earthquake that devastated the San Francisco Bay Area. That quake measured 6.9. A magnitude 7.3 releases approximately 2.5 times more energy. The destruction would be catastrophic. But the magnitude is not what terrifies geologists most. The timeline is, research teams from the University of Nevada and the United States Geological Survey have spent years analyzing sediment cores pulled from the lake bottom. They studied underwater fault scarps and examined evidence of ancient ruptures preserved in the geological record. Their conclusion was alarming. The West Tahoe Fault lasts ruptured approximately 4,000 years ago. Based on the fault's slip rate and accumulated strain, scientists calculate it is now overdue for another major event. 4,000 years of pressure building along fractured bedrock. 4,000 years of tension accumulating in rock that will eventually fail. The fault system beneath Tahoe is not a single clean fracture. It's a complex network of interconnected segments that could rupture together in a cascading failure. The West Tahoe Fault connects with other fault systems running through the basin, creating a web of geological instability hidden beneath one of America's most beloved vacation destinations. This fault receives a fraction of the attention given to the San Andreas. No Hollywood movies dramatize its threat. Few tourists visiting the lake's crystal waters know they are swimming above a ticking time bomb. But seismologists ranking California's earthquake hazards place the Tahoe Basin among the most concerning regions in the state. And now, there's a new variable. Billions of tons of water pressing down on that overdue fault with maximum force. Water is heavy, far heavier than most people realize. A single cubic foot weighs 62 pounds. Lake Tahoe at maximum capacity holds approximately 39 trillion gallons. The math is staggering. Billions of tons of pressure pushing down on the lakebed every second of every day. This weight doesn't simply rest on solid ground. It presses against fractured bedrock. It infiltrates cracks and fissures in the geological structure below. And when that weight sits directly above an active fault system, it creates conditions that seismologists have witnessed triggering earthquakes around the world. The phenomenon is called induced seismicity. Large bodies of water can cause earthquakes. This is not theory, it's documented fact. In 1967, India's Koyna Dam Reservoir triggered a magnitude 6.3 earthquake that killed 180 people. Lake Mead behind Hoover Dam has generated hundreds of small earthquakes since it filled in the 1930s. China's Zipingpu Reservoir may have contributed to the devastating 2008 Sichuan earthquake that killed nearly 70,000 people. Scientists continue debating the connection, but the pattern is undeniable. Water triggers earthquakes through two mechanisms. The sheer weight adds vertical pressure to fault systems already under horizontal tectonic stress. But the more insidious effect happens underground. Water seeps into rock fractures and increases what geologists call pore pressure. This pressure reduces the friction that keeps fault surfaces locked together. Essentially, water lubricates the fault plane, making it easier for accumulated strain to release suddenly and violently. Lake Tahoe now sits at maximum capacity, maximum weight, maximum pressure, all of it bearing down on the West Tahoe Fault, which has been accumulating strain for 4,000 years. The fault is already stressed beyond its typical rupture cycle. Now, billions of additional tons are pressing against it. Scientists monitoring the region understand what this combination represents. An overdue fault, maximum water load, reduced friction along fracture planes. The elements are aligning for a potential disaster, and the instruments are detecting exactly what they feared. The fault is responding. The seismographs are not lying. Something is happening beneath Lake Tahoe, and the data is getting harder to ignore. Recent monitoring from stations positioned around the Tahoe Basin reveals a disturbing pattern. Small earthquakes are increasing in frequency along the West Tahoe fault system. Magnitude 1.9 tremors have been detected in recent months. These quakes are too small for humans to feel, but the instruments feel everything. Seismologists call these events micro-seismic activity. To the untrained eye, a magnitude 1.9 earthquake seems meaningless, barely a whisper in the geological record. But earthquake scientists recognize these small tremors as potential precursors, warning shots from a fault system under increasing stress. The historical record supports their concern. Before major earthquakes, fault systems often exhibit increased microseismic activity. Small ruptures along fault segments release tiny amounts of accumulated strain. These events can indicate that larger sections of the fault are approaching failure. The 2011 Tohoku earthquake that devastated Japan was preceded by an increase in smaller quakes. The pattern repeated before other major ruptures worldwide. Monitoring stations around Lake Tahoe now operate around the clock. University researchers and USGS scientists analyze every tremor, mapping locations and measuring depths. They track the frequency of events week by week. The baseline is shifting. Activity levels that would have seemed normal 5 years ago now appear elevated against the backdrop of maximum water pressure. The challenge is interpretation. Earthquake prediction remains one of science's most elusive goals. Small tremors might indicate an imminent major rupture. They might also release enough strain to delay a larger event, or they might mean nothing at all. Scientists cannot say with certainty which scenario is unfolding. What they can say is this: the combination of factors present at Lake Tahoe demands vigilance, an overdue fault, maximum water load, increasing seismic activity. Each element alone would warrant attention. Together, they create conditions that no researcher is willing to dismiss. The instruments keep recording, the tremors keep coming, and the scientists keep watching. If the West Tahoe fault ruptures while the lake sits at maximum capacity, the earthquake will only be the beginning. What follows could be far worse. Lake Tahoe's underwater terrain is not a gentle slope. The lake plunges to depths exceeding 1,600 feet with near vertical walls in some areas. Massive underwater slopes of loose sediment cling to these steep gradients. A magnitude 7.3 earthquake would shake these formations violently. Scientists believe the result would be catastrophic underwater landslides, millions of tons of sediment collapsing into the lake's depths simultaneously. When that much material displaces that much water that quickly, it generates a tsunami. This is not speculation. Geological evidence confirms it has happened before. Researchers studying lakebed sediments have identified massive underwater landslide deposits from prehistoric events. The McKinney Bay landslide moved approximately 12 cubic miles of material in a single ancient catastrophe. The wave it generated would have been devastating. Modern modeling projects what a similar event would produce today. Waves potentially reaching 30 feet or higher, traveling across the lake at speeds approaching 100 miles per hour. Shoreline communities would have almost no warning. The geography that makes Tahoe beautiful also makes it deadly. The lake is only 12 miles wide at its broadest point. A tsunami generated on one side reaches the opposite shore within minutes. Ocean tsunamis give coastal populations time to evacuate. Warning systems detect distant earthquakes and issue alerts hours before waves arrive. Lake Tahoe offers no such luxury. The earthquake and the tsunami would arrive almost simultaneously. Communities would feel the ground shaking and see the wave approaching within the same terrible minutes. The enclosed basin creates another nightmare. Unlike ocean tsunamis that dissipate across open water, a lake tsunami reflects off the surrounding shoreline. Waves bounce back and forth across the basin, striking communities multiple times. The initial wave is only the first assault. 2 states, dozens of communities, minutes to impact. No meaningful warning system in place. South Lake Tahoe, Tahoe City, Incline Village, Kings Beach, State Line. These are not just names on a map, they are communities, families, homes built along one of America's most spectacular shorelines. And they sit directly in the path of a potential catastrophe most residents know nothing about. Approximately 55,000 people live in the Lake Tahoe Basin year-round, but that number explodes during peak tourist season. Summer weekends bring over 100,000 visitors to the shoreline. Ski season packs the Nevada casinos and California resorts with thousands more. On any given holiday weekend, the population around the lake can triple. These people would have minutes to respond to a tsunami. Most would have no idea what was happening until the wave arrived. The geography creates a deadly trap. Lake Tahoe sits in a mountain basin accessible by a handful of 2-lane highways. Route 28 hugs the north shore. Highway 50 winds along the south. Route 89 traces the western edge. During normal summer traffic, these roads jam with vacationers. During a mass evacuation, they would become parking lots. Emergency management faces a jurisdictional nightmare. The lake straddles California and Nevada. 5 counties share responsibility for shoreline communities, 2 state governments, multiple fire districts, dozens of local agencies that would need to coordinate instantly during a crisis that unfolds in minutes. The warning system gap is alarming. Ocean-facing communities have tsunami sirens and established evacuation routes. Lake Tahoe has neither. No sirens, no clearly marked tsunami evacuation zones, no public education campaigns warning residents about the fault beneath their feet. Property values along the shoreline exceed $15 billion. Luxury homes, historic resorts, marinas filled with boats, commercial districts catering to millions of annual visitors, all of it built on the assumption that the serene blue water poses no threat. Most residents move to Tahoe for its beauty, its tranquility, its escape from urban chaos. Few realize they have built their lives above a fault that has been waiting 4,000 years to move. Inside monitoring stations scattered around the Tahoe Basin, seismographs trace their endless lines across digital screens. Every tremor registers. Every shift in the Earth's crust leaves its signature. Scientists watch these readings with the patience of hunters, waiting for prey they know will eventually appear. The technology has never been better. Modern seismic networks detect earthquakes too small to feel. GPS stations measure ground deformation down to millimeters. Satellite imagery tracks surface changes invisible to the human eye. Researchers can monitor the West Tahoe fault with a precision previous generations could not imagine. But one fundamental limitation remains. Earthquakes cannot be predicted. Scientists can identify faults. They can calculate probability. They can recognize warning signs. What they cannot do is tell you when. The Earth does not announce its intentions. A fault can remain locked for centuries past its average rupture interval, or it can fail tomorrow. The uncertainty is maddening and unavoidable. Research teams continue studying the Tahoe Basin, hoping to improve understanding. University of Nevada seismologists analyze tremor patterns for anomalies. United States Geological Survey scientists refine hazard models, incorporating new data about the fault system. Graduate students spend years examining sediment cores that reveal prehistoric catastrophes. Funding remains a constant struggle. The West Tahoe fault generates no headlines. No dramatic ruptures in living memory keep it in public consciousness. Research dollars flow toward the San Andreas and other famous fault systems, while Tahoe's hidden threat receives a fraction of the attention scientists believe it deserves. The expert consensus is uncomfortable. The fault will rupture. This is not speculation, but geological certainty. Faults that accumulate strain eventually release it. The West Tahoe fault has been building pressure for 4,000 years. That pressure will find release. The only questions are when and how violently. Until then, the scientists watch. The instruments record. The data accumulates. And the fault beneath Lake Tahoe continues its slow march toward an inevitable conclusion that no one can schedule. Lake Tahoe stretches across the Sierra Nevada like a mirror, reflecting everything except the truth beneath its surface. Visitors see crystal blue water, pristine mountain scenery, one of nature's most perfect creations. They photograph sunsets from the shore. They post images to social media celebrating paradise found. They do not see what lies below. They do not know what is waiting. The water has reached 6,229 feet, maximum capacity. Billions of tons pressing against the earth with relentless force. After 5 years of devastating drought, the lake recovered faster than anyone predicted. Atmospheric rivers delivered what climate scientists feared might never return. Headlines called it a miracle. Water managers exhaled with relief. But scientists monitoring the region see something else entirely. Something that turns celebration into dread. 25 miles of fractured rock run beneath that beautiful surface. The West Tahoe Fault has been accumulating strain since before humans built their first permanent structures. 4,000 years of tension building in bedrock that humans cannot see and most do not know exists. The fault does not care about property values, tourism revenue, or holiday weekends. It follows geological time, not human schedules. Geological time is patient beyond comprehension. Small tremors continue registering on seismographs positioned around the basin. Each one leaves its mark on the data. Researchers analyze patterns that might mean everything or nothing. The instruments cannot tell us when the fault will fail. They can only confirm that the earth beneath Lake Tahoe is restless, that something is shifting in the darkness below. 55,000 residents live around this lake year-round. Millions more visit each year seeking escape from ordinary life. They swim in the water. They boat across the surface. They build luxury homes along the shore. They raise families above a fault capable of magnitude 7.3 devastation and tsunamis that could arrive within minutes. Most will never read a scientific paper about the West Tahoe Fault. Most will never attend a community meeting about seismic hazards. Most will never know what they are living above until the ground begins to shake. The emergency management gaps remain unfilled. No tsunami sirens line the shoreline. No evacuation routes designed for waves that arrive in minutes have been established. No public awareness campaigns explain what lurks beneath paradise. 2 states share jurisdiction. 5 counties divide responsibility. And the fault waits for no bureaucracy to coordinate its response. Scientists understand what is coming. Not today. Perhaps not this decade. Perhaps not this century. But eventually, geological certainty offers no comfort and no timeline. The fault will rupture because faults always rupture. Strain that accumulates must eventually release. This is not opinion. This is physics. Lake Tahoe has reached its limit. Billions of gallons pressing down on ancient fractures with maximum force. The surface remains calm and impossibly blue. Tourists continue arriving. Families continue swimming. Life continues as if the danger does not exist. But beneath that postcard perfection, the pressure continues building. The tremors continue registering. And the question that haunts every seismologist studying this region grows harder to ignore with each passing day. Has the fault beneath America's most beautiful lake finally reached its limit too?